Welcome to this two-part series on electromagnetic compatibility, or EMC. To understand EMC, we need to introduce EMI, and we'll start by first talking about electromagnetic waves. What are electromagnetic waves? In the 19th century, Michael Faraday, Joseph Henry, and James Maxwell established that electrical and magnetic signals are linked. A changing magnetic field induces a changing electric field, and vice versa. These changing fields create electromagnetic waves. Electromagnetic energy is all around us, from 50 to 60 Hz electrical power to audible frequency and AM/FM radio. Microwaves, infrared, visible light, ultraviolet light, X-rays, and gamma rays are also different forms of electromagnetic waves. The electromagnetic spectrum distributes electromagnetic energy according to frequency and wavelength. High-speed switching of electrical and electronic devices can also generate electromagnetic signals. To understand what issues electromagnetic compatibility, or EMC, prevents, we'll need to look at two types of interference: radio frequency interference and electromagnetic interference. Radio frequency interference, or RFI, is when unwanted noise from 15 kHz to 1000 MHz causes issues due to electromagnetic energy. Electromagnetic interference, or EMI, is the term for when interference could come from any frequency, encompassing both radio and microwaves. EMI is a phenomenon that can range from a nuisance to a disaster, depending on what it impacts. For instance, interference with your television or radio may be bothersome but will not have much overall impact. On the other hand, interference with a pacemaker or other medical device could have devastating consequences. It's why EMC is so essential. At the turn of the century, this created a need for regulating EMI to safer limits, giving rise to electromagnetic compatibility requirements. Today's high-power, high-speed switching electronics, such as triacs, MOSFETs, or SCR, generate very high levels of unwanted electromagnetic signals. This is called electromagnetic noise, or simply noise. These unwanted signals can propagate to other electronic systems in the vicinity, causing nuisance, malfunction, or disruption. This is the electromagnetic interference, or EMI, phenomenon. EMI comes from both natural and man-made sources. Natural sources are beyond our control and include electrostatic discharge from a lightning strike or coronal mass ejection following large solar flares. Controlling man-made EMI is the focus of EMC. Two broad categories of man-made EMI sources are 1. Intentional and 2. Unintentional. Intentional sources require electromagnetic waves for their intended operation, such as cell phones, TV, and radio. These EM signals are necessary and can't be limited. The only way to mitigate their impact is by protecting other equipment from these. As an example, cell phone use is not allowed in many hospitals. Unintentional sources create undesired electromagnetic noise during their operation. These are major disruptors to other devices in the vicinity. The unintended sources include motors, electric appliances, inverters, rectifiers, treadmills, and others. The noise from these unintentional sources must be suppressed to ensure proper operation of other nearby devices. Let's define a few terms to close out the basics of EMI and RFI. What is a source? Electrical equipment generating and propagating the EMI or noise is called a source. Examples include cell phones, appliances, computers, treadmills, inverters, welding machines, etc. What is a receiver? Electrical equipment that receives unwanted noise signals, or EMI, is called a receiver. If the receiver gets adversely impacted by this EMI, it can also be called a victim. Cell phones, TVs, and computers can be a receiver as well as a source. Other receivers include electronic modules, medical equipment, and touch panels. What is coupling? Coupling is the mechanism by which electromagnetic emissions interfere with other susceptible electrical equipment. EMI can propagate via two routes: conducted over electrical cables and power lines, or radiated over the air using the electrical wires, PCB traces, or component leads of transmitter and receiver antennas. Now that you understand the basics of EMI and RFI, check out our video EMC 102, What is EMC? To continue learning about this topic. Its link is in the description. Once you understand EMC design, you can minimize unwanted emissions, comply with all internal and external EMC regulations, and pass EMC compliance testing the first time. If your devices need compliance testing or supplies to reduce EMI issues, contact Astrodyne TDI for a custom quote today.